expansion of e raised to x, 1 plus x square by 2 factorial plus x cube divided by 3 factorial and so on. Then e raised to minus x, 1 minus x plus x square by 2 factorial minus x cube by 3 factorial and so on. Sin x is odd function. Sin of 0 is 0, therefore there is no any constant term. The expansion starts from x, the odd degree term, and remaining terms are odd degree terms. X minus x cube divided by 3 factorial plus x raised to 5 by 5 factorial and so on. Cos x, cos 0, 1. So expansion start with the constant term 1. 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial, even degree terms. Tan x is x plus x cube by 3 plus 2 by 15 x raised to 5 and so on. Okay. In the same way, we can write the expansion of sine hyperbolic of x, cos hyperbolic of x, tan hyperbolic of x. Then we have written the expansion of log 1 plus x. That is x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4. Then log 1 minus x is written, x is replaced by minus x. Then 1 upon 1 plus x, 1 upon 1 minus x, and 1 plus x raised to n is written. Okay. Then we solve few examples. We solve this example, sin x into cos hyperbolic of x. Then we solve e raised to x into cos x. We obtain the expansion of x raised to 4. Then we obtain expansion of root of 1 plus sin x. Okay. Now we'll go through the fourth example. Let me start the live mode. 1 minute only. Yes, live mode started. Let me go through the next example. Right with me now. So now see, till whatever examples we solved, they were direct examples. Now sometime the example, the function, given function, it is not in the standard form. But somehow we have to use this, whatever the 13 standard expansions are given, now we have to use them. Now what is meaning of this? We'll understand it from the next example. Yes, right with me. Expand. One minute, okay. Yes, now write with me. Example number 4. Expand log of 1 plus x square plus x cube up to x raised to 4. Yes. Solution, Radha? Let y equal to log of 1 plus x square plus x cube. Remember that whenever we have logarithmic terms, we can simplify the expansion, right? So anyone, how we can find the required expansion? You can go through the 13 formulas that we have already written. So you go through the first formula.
Sir, I think we have to take x common.
Okay. Then
the third x square, we have to take x common, then x plus 1.
Okay. So like this, you want to say like this, log of, see, keep the first two terms as it is. From the third and fourth term, we can take x square common. So it will remain 1 plus x. Okay.
Yes, sir. Yes, sir.
This is what you want to say. From this is the first term and this is the second term. From first and second term, we can take 1 plus x common. Then what will remain? 1 plus x square will remain. And hope everyone remember this formula. Log of AB.
A plus log of A plus log of B.
Log A into B. That is log A plus log B. Okay. So let me use this formula. So it will be log of 1 plus x plus log of 1 plus x square. Now we know the formula. So use the known formula of expansion of log of 1 plus x. What is the expansion? We have to start with the x minus x square divided by 2 plus x cube divided by 3 minus x raised to 4 by 4. I am not writing the remaining terms since again our aim is to find expansion up to x raised to 4 only. Therefore, So using this, this is the y, this is the y. So y equal to expansion of this term. Just I have to write the formula only. That's it. Okay. So x minus x square divided by 2 plus x cube divided by 3 minus x raised to 4 by 4. Okay, and higher degree terms plus now I have to write the expansion of log of 1 plus x square. So in the formula I have to replace x by x square, right now. So x square minus x square square, so x raised to 4 divided by 2 plus x square cube, so x raised to 6 divided by 3 and remaining terms, and since they are higher degree terms they are not required, so I am not writing them. Hope it is clear to you. Now just you have to simplify it. Simplify on the right side. Yes, therefore y equal to x, then x square term there are 2, x square minus x square by 2, x cube single term, x cube divided by 3 plus x raised to 4. Yes, both of them are negative only, minus x raised to 4 by 4 plus x raised to 4 by 2. Negative sign is taken outside. Simplify this. So y equal to, add the expansion, y equal to x plus x square divided by 2 plus x cube divided by 3 minus 3 by 4 x raised to 4. This is the required expansion. Hope it is clear to you.
Yes.
Yes, sir.
Okay, great. Sure. Next. Page number 8. Let me change the page. Let me go to the next example. Again, I'm expecting answer from everyone. I'll give you 2 minutes to solve the example. See whether you are able to solve it. So, example is like this. Expand. Page number 9. Let expand 1 plus x raised to x up to x raised to 4. Yes. Which formula, which method, or which concept is to be used?
1 plus x to the power n.
No, see,
Sir,
whenever
here, it is a variable, so we can't accept.
correct. 1 plus x raised to n. Understand the difference. This x is a variable. Right? What is meaning of variable? Y depends upon x. This type of variable, dependent and independent variable. Whereas, what about the n? N is some real number.
Real number.
In fact, in case of binomial expansion, it is a whole number. Right? Now, maybe 5, maybe 7, like this. So x and n, they have different rule. So this formula cannot be used. Huh? So this cannot be used. Yes. What else we can do?
Sir, taking log on both sides.
Okay, so we can take log on both sides, right? Y equal to 1 plus x raised to x. Then write down taking log on both sides. I think you will understand it. So log of y equal to x log of 1 plus x. Now expansion of 1 plus x is known to us. Use that. X minus x square by 2 plus x cube divided by 3 minus x raised to 4 by 4 and so on. Simplify this. multiplied by x. So x square minus x cube divided by 2 plus x raised to 4 divided by 3 minus x raised to 5 divided by 4. Okay, let me consider this as a z. Why? We'll understand why I'm considering this as a z. But right now we have log y equal to this whole term or say equal to z. Right? But our aim is to find y. So taking antilog, take antilog, take antilog on both sides. So y equal to e raised to this whole term, that is z. Right now? But we know what is e raised to z is. What is the expansion of e raised to z? 1 plus
1 plus
z.
z plus z.
Yes, divided by 2 factorial plus z cube divided by 3 factorial and so on. Let me write this as 1. Now our aim is to get this z, z square, z cube. And while finding this z, z square, z cube, every time we have to remember that our aim is to find expansion of 2x raised to 4 only. Yes, now try to find z, z square. Write them and try to find it. Right. Here z equal to written here. Here we have written x square minus x cube by 2 plus x raised to 4 by 3. That's it, huh? Next term is not required. We have to consider terms up to x raised to 4 only, therefore.
Yes, sir.
Z square. Now write the z square. Z square equal to z square equal to z into z. Or use your own method, no problem. It's not required that whatever I'm writing, only you have to follow that. Usually in mathematics, there are alternate methods and you can use any method. There is no any problem. Yes, term by term multiplication as we have done in previous case. Multiply the second bracket by x square first. So x raised to 4. Next is x raised to 5, not required. In fact, this is the only term.
Okay.
If you multiply by any other term, you will get x raised to 5 or higher degree terms. Then tell me what will happen in case of z cube. Hope you remember the concept that we studied, lowest degree term concept. Remember, na?
Yes, sir.
Right. So what is lowest degree term in z cube? Lowest degree term in z.
X to
It's
the power
cube
6.
and higher degree terms then. So it is lowest degree term in z is x square.
X square.
Right, it's cube and then remaining term. So x raised to 6 and remaining term. So is it required? No.
No.
Why? Since again our aim is to find expansion of 2x raised to 4 only, therefore. Hope everyone is getting this.
Yes, sir.
Very good. So substituting above values in 1. So see what is 1 is. So 1 is y equal to 1 plus z square divided by 2 factorial and so on. So 1 plus x square minus x cube by 2 plus x raised to 4 by 3 and so on plus 1 upon 2 single term x raised to 4 higher degree terms. So simplification will be like this: 1 plus x square minus x cube by 2 and 1 upon 3 plus 1 upon 2. These are the coefficients of x raised to 4 and higher degree terms. So the final answer is y equal to 1 plus x square minus x cube by 2 plus 5 by 6 x raised to 4. This is the answer. Hope this is clear to you.
Yes, sir.
Yes. Next example. Can I change the page? Have you written everything?
Yes, sir.
Yes, sir.
Yes.
Okay. Example number 10. Sorry, page number 10. Next example, I think 6th, 7th, whatever it is. Expand 1 plus x raised to 1 upon x. Expand 1 plus x raised to 1 upon x up to x square. Solution. Let y equal to. Okay, so take log on both sides. As we have done in previous case. Multiply by 1 upon x. Hope up to this step everything is clear.
Yes,
Yes, sir. Yes, sir.
sir.
Yes. Now, can anyone tell me what should be z so that will able to terminate the expansion somewhere? That is, it may not be required to consider any term from z cube, z raised to 4, z raised to 5, like this. Okay. Other way around. Suppose I consider like this. Understand what happens. Suppose I consider it as e raised to z. Okay, then what is e raised to z? 1 plus z square divided by 2 factorial plus z cube divided by 3 factorial and so on. Okay, now tell me which is lowest degree term in z. What the z is 1 minus x by 2 and so on. Na? X square divided by 3 and so on. So which is lowest degree term? 1. What will be lowest degree term in z raised to 5?
1.
1 raised to 5. That will be 1 only, na?
1.
Right now. So if we consider z in this way, it means that we cannot terminate the expansion anywhere, and it is due to this one. Right? Problem is due to this one. Problem is due to this one. So we should able to remove this one. Okay. So in this way, if you try to solve the example in this way, it's not possible to get the answer. सबको समझ में आ रहा है? Everyone is getting this point. What I am saying. If I
Yes,
consider z starting from 1, the lowest degree term in z is 1, lowest degree term in z raised to 5, z raised to 10, z raised to 17, whatever the numbers, will be 1 only.
Yes, sir.
And as in previous example, we consider terms up to z square only. Z cube was x raised to 6, therefore we not considered z cube, z raised to 4, z raised to 7. Since we want expansion up to x raised to 4. I am saying about the previous example. Right, so here we should remove this one. And how to remove this one? Very simple. You do it in this way. Okay, so I'll write on the next page. So y equal to e raised to, I'm separating 1 and I'm separating the remaining terms, x by 2 minus x by 2, yes, plus x square by 3 minus x cube by 4 and so on. Okay, and now we'll consider it in this way. Y equal to e and e raised to z. So e, and now it is e raised to z, 1 plus z square divided by 2 factorial and so on. Which is 1. Hope everyone is getting this. Here z equal to minus x by 2 plus x square by 3. Now understand that our aim is to find expansion up to x square only. Up to x square only. Okay. Now find z square. If anyone is not getting a particular step, please ask me. In online mode, it is difficult to understand whether everyone is getting whatever I am teaching or not. It is very difficult to understand it. So now the responsibility on your side is increased. Okay. So now let me multiply the second bracket by first term minus x by 2. So x square by 4. Right. Next term is x cube term, so not required. Plus now multiply by second term. So it is x cube term, so not required. Not required. So single term only. X square divided by 4. What about z cube? Lowest degree term in z, so minus x by 2. Its cube and then higher degree term. So x cube divided by 8 and then higher degree. So we should not consider z cube also. Why? Again, our aim is to find expansion up to x square only. Therefore, so substituting values in 1. Yes, substitute them in 1 and see what you are getting. So 1 is y equal to e 1 plus z square divided by 2 factorial and so on. So e 1, then z is minus x by 2 plus x square by 3, then 1 upon 2 x square by 4, and then higher degree terms. So simplify. 1 minus x by 2, 1 by 3 plus 1 by 8. So 11 by 24. This is the expansion.
Yes, sir, getting the answer.
Yes, good.
Sir,
Uh-huh.
so can you please tell the reason why you discarded that method and you split into 2 e raised to 1 into e raised to minus x by 2?
Okay. See, now from here it is clear. You see the right part, So here what I have written, 1 plus z square by 2 factorial. What will be the next term? Z cube by 3 factorial and so on, right?
Yes.
Let me change the ink. Okay. So z cube by 3 factorial and so on, right? Our aim is to get expansion up to x square only, right? Then we started with the z. In case of z, we are getting two required terms, minus x by 2 and x square by 3. Clear? In case of z square, we are getting single term, x square by 4. Other terms are there, but they are higher degree terms, and we are not considering higher degree terms. Understood?
Yes,
Right. Now, whereas in case of z cube, the expansion itself starts from x cube by 8. So, is it required to consider any term from z cube? No. Since this is x cube by 8, next will be, for example, x raised to 4 by say 17. Next maybe x raised to 5 by say 81. Like this. Getting now?
Yes, sir.
Therefore, while writing, here I have not written z cube. Getting now? Here I have not written z cube.
Yes, sir.
Right. So here it is not required to write z cube, z raised to 4, z raised to 7. Right. It is required to consider terms from z and z square only. And again, we are not considering all the terms. We are considering only two terms from z, single term from z square. Those are the only terms up to x square. Those are the only required term. Understood?
Yes, sir.
Now go to this part. Okay. Now see here. Let me change the ink. Okay, this will be better. See here, if we consider z in this way, in this way, if we start z from 1, right? Now we have to consider 3 terms from z. If we find z raised to 5, 1 will be there, na?
Yes.
So we have to consider z raised to 5 also. If we find z raised to 100, z raised to 100, what will be the lowest degree term? 1 only, na?
1.
Right, na?
Yes.
If we find z raised to 1 billion,
No,
what
sir,
will be the
only
lowest
one.
degree term?
1
1.
only.
So can we consider terms up to z raised to billion? No.
No,
Or
sir.
in other words, can we terminate the expansion somewhere? As we terminated in this case, in this case, we terminated it here up to z square only, which is not possible in case of this part when we start z from 1. Now
Yes, sir.
clear or not?
Yes, sir. Clear.
Understood? Everyone else also understood?
Yes,
Yes,
sir.
sir.
Okay, great. Chalo. Next.
Yes, sir.
Yes, very good. Next. This is all about the standard expansions. Few examples will be given for homework. I will post the homework today only so that you can practice it maybe today or tomorrow and submit it by Monday. Okay. So we'll go through the third method. Next, Radha. Next page, page number 11. Okay, right. Type number 3. Type 3. Right. Use of differentiation and integration. Use of differentiation and integration. We'll go through example directly and we'll try to understand how we can use differentiation and integration to find expansion of some standard functions. Expand tan inverse x in ascending powers of x. If you want to write it or you leave it. Let y equal to tan inverse x. So we don't know expansion of tan inverse x. Okay, so what we'll do, we'll differentiate this. Again, question may be why we are differentiating, so we'll understand it. Okay, so differentiating with respect to x. So what is dy by dx? What is the derivative of tan inverse x? 1 upon
1 plus x square.
X square, absolutely. Then we know the formula of 1 upon 1 plus x. Right? So let me write this using, I'm writing it in terms of t. So 1 upon 1 plus t. What is the expansion? 1 minus t plus t square minus t cube. Hope everyone remember this. Right? So using that, the above differential equation, that will become dy by dx equal to, so we have to replace t by x square. Right? If you compare these two, you will get t equal to x square. So 1 minus x square plus x raised to 4 minus x raised to 6 and so on. And this is the differential equation. And we know how to solve the differential equation. How to solve the differential equation? We have to write y on one side and
x on one
variable
side.
on others.
Separable method. Variable
very
separable.
good. Separation of variable or variable separable method. Very good. Variables are separated. Now integrate. From where to where? From 0 to x. You can decide it. How to consider the limit now? You can decide. You can consider from 1 to x also. But if you consider 1 to x, the problem becomes somewhat complex. How? We'll understand. Timing, let me consider it as 0 to x. dy 0 to x 1 minus x square plus x raised to 4 minus x raised to 6 and so on. Definite integral, therefore no need to add any constant. Integration of dy is y, but y is function of x. So let me write like this. Whereas on other side, what the value of integral is? X. Integration of x square is x cube divided by 3. plus x raised to 5 divided by 5 minus x raised to 7 by 7 and now so on, and limits are 0 to x. Yes, we can substitute the limits now and see what we are getting. So I'll write on the next page. Okay, so y of x minus y of 0 equal to, upper limit is x, so it is x minus x cubed by 3 plus x raised to 5 by 5 minus x raised to 7 by 7 and so on. This is upper limit. Substitute lower limit x equal to 0 and all the terms are zeros. But y of x equal to tan inverse x. Whether I write y or y of x, one and same only. Okay, which implies y of 0. Tan inverse 0 equal to 0. Okay, so it is like this: tan inverse x minus 0 equal to x minus x cubed by 3 and so on. That is tan inverse x equal to x minus x cubed by 3 plus x raised to 5 by 5 minus x raised to 7 by 7 and so on. Okay, one interesting thing that we can conclude from here is result. Not part of syllabus. Huh? Next part, this result part, it is not part of the syllabus. So see what we'll do now. Na? We'll integrate with respect to whatever integration limits we substituted, na? 0 to x. Now let me consider 0 to 1 and we'll see what will happen. 1 to x. 1 to x dy equal to 1 to x and the remaining things. What it was? 1 minus x square plus x raised to 4 minus x raised to 6 and so on. Dx. Please do it yourself. So it is y of x 1 to x equal to x minus x cubed by 3 this is y of x minus y of 1 equal to minus substitute 1 minus 1 upon 3 plus 1 upon 5 minus 1 upon 7, isn't it? Can anyone tell me what is y of 1?
5 by 4.
Absolutely. Right. Since y of x is tan inverse x, y of 1 is tan inverse 1 and that is pi by 4. Achha, can you find any conclusion from here about pi by 4? Yes, anyone? What is y of x? Y of x kya hai? What is y
Tan
of
inverse
x?
x.
Tan inverse x. And from above result, we know the expansion of tan inverse x, na?
Yes.
Right?
Yes,
So can I cancel these two?
Yes, sir.
Yes, sir.
Right? Na? So what is y of 1? The series is y of 1. अरे जपते कि नहीं? अरे ये जो y of 1 है ना, इतना समझ में आता है या नहीं मैथ्स? ये जो y of 1 है, that is equal to this bracket.
Yes, sir.
First brackets are equal on
Yes,
both
sir.
the sides. So second bracket will be no doubt equal. But what is y of 1? Pi by 4. So can I write like this? Pi by 4 equal to 1 minus 1 upon 3 plus 1 upon 5 minus 1 upon 7 plus 1 upon 9 minus 1 upon 11 and so on. Is it possible?
नो सर,
No, sir.
एक रैशनल है और दूसरा इरेशनल है सर.
No. This is irrational, okay?
Left side is irrational. Right is rational. It can come rational. It
No,
is
see,
rational.
if we take the particular number 1 upon 5, 1 upon 7, 1 upon 9, no doubt they are rational. But we don't know
Yes,
what
yes,
will
yes.
happen if we consider
When,
their addition and subtraction. No?
sir, whenever pi by 4 comes, if you want rational values, then we will substitute this, I think.
No, you think other way around. See, here our aim is not to find the value of pi by 4. Okay. Here our aim is to find the sum of series, which is a very difficult part. मैं क्या बोल रहा हूँ समझ में, you try to understand it. Our aim is not to find the value of pi or pi by 4. Aim is to find value of the series, infinite series. And this is one of the way to find the infinite series. Okay. Now you can try with different values. You can take instead of 1 to x, you can take 2 to x, 5 to x, and see what values you are getting. Okay. This is one of the application of whatever we are studying, expansion of the function. Right. Then another way is there to find sum of the series that we'll study in the unit number 2, Fourier series. Okay. So there are n number of, now understand what I'm saying. There are n number of methods to find sum of series. Still, there are few series whose sum is not known till today. Understood? And this may be challenge against you. You find the sum of those series. Okay. Let me continue. So, right, next example. These next few examples, they are for the homework. Homework. Let me change the page. Any doubt here? Can I change the page now?
Yes, sir.
Yes, sir.
Right, 12. Right, homework. Expand. Okay, next item. Standard expansions. The standard expansions which are obtained using the method of derivative and integration. They are here, right? 1. Sine inverse x. Right? Question is asked above and answer is written here. X plus 1 upon 2 x cube divided by 3. 1, 2, 3, 4. X raised to 5 divided by 5 plus 1, 2, 3, 4, 5, 6. X raised to 7 divided by 7 and so on. Expansion of sine inverse x is like this. Then write cos inverse x. Cos inverse x is pi by 2 minus sine inverse x. Therefore, it is pi by 2 minus expansion of sine inverse x. Okay, then third is tan inverse x, already known to us. So minus x raised to 7 by 7. Fourth. Same as sine inverse x, only the signs are different. There is no any relation in case of hyperbolic function that exists in case of cos inverse x and sin inverse x. This type of relation does not exist in terms of sin hyperbolic inverse x and cos hyperbolic inverse x. Why? Whenever I'll get the time, I will explain what the hyperbolic functions are, what is the relation between hyperbolic function and circular function, and there I'll tell you why this type of relation does not exist. Okay, timing, let me continue. No doubt somewhere we have to study the hyperbolic function since we are using them again and again. So maybe in next few lectures we'll try to understand them. All the terms are positive. So 13 and these 5 expansions. In all there are 18 standard expansions that you have to remember. आपको इसको याद रखना है. By tomorrow you have to remember it. Tomorrow, whenever we'll start, whenever the next lecture will be there, I'll ask you what are the formulas. Okay. So next method. Now whatever formulas we studied here, you have to use them. Written everything?
Yes, sir.
Can I go to the
Yes,
next
sir.
method? So type number 4. Substitution method. I think everyone is aware about the trigonometric formulas, but let me revise them, so that whenever they are required, we can refer them. So write with me: sin 2 theta.
2 sin theta into cos theta.
Okay, in terms of tan,
2 tan theta upon 1 plus tan square theta.
1 plus tan square theta. Very good. Cos 2 theta.
2 cos square theta minus 1.
Cos square theta minus sin square theta.
So that
1
is equal
minus
to 2 cos square theta minus 1. Good.
1 minus
1
tan
minus
square
2 sin square theta. Good. Then
1 minus
in terms of
tan
tan,
square theta. 1 minus tan square theta upon 1 plus tan square theta.
absolutely. Okay. Tan 2 theta.
2 tan theta upon 1 minus tan square theta.
Absolutely. Sin 3 theta.
3
3
sin
sin theta minus 4 sin cube theta.
Very good. Cos 3 theta.
4
4
cos
cos
cube
theta
theta
minus
minus
3 cos
3.
theta.
Very good.
4 cos. Yes.
Anyone remember tan 3 theta formula?
Sir, it is in
3
the
tan
form
theta minus
3s1.
tan
3 tan
cube
theta
theta
minus
upon
tan cube
1
theta
minus 3
upon
tan square
1
theta.
minus 3 tan square theta.
1 minus
3
3
tan
tan
square
Tan
theta.
theta.
Okay. Okay, right next. Hyperbolic formulas are also there. I think somewhere we should start understanding hyperbolic formulas. We are writing them again and again. So how much time we have? 10 minutes only. 10 minutes are not sufficient. So in next lecture, we'll try to understand hyperbolic formulas, since we are using them again and again. So timing, let me continue with the circular formulas only. So right, tan inverse A plus tan inverse B. Tan inverse
A plus
A
B
plus B upon 1 plus AB.
1
1
minus A.
minus AB. 1 minus AB.
If it is minus here,
Then it
minus here
Sine will
and
rotate.
plus here. Then I think you might know this, minus of sine theta, other way around, That is equal to sine of Minus.
minus
But
theta.
what about minus of cos theta? Anyone?
cos theta
Cos
Cos
theta.
theta. Cos theta.
minus
No,
sin
no, no.
theta.
See, cos of minus
cos
theta
theta
is cos theta. But what
कितना
about
बजे
minus
हो?
cos theta? So, what should be the angle? Right? I have to write some angle over here so that it will be minus cos theta.
Yes, yes.
Pi minus theta.
Pi minus theta.
Pi plus or minus, both will work.
Yes, sir.
Pi plus minus theta.
Theta.
And last formula. Cot of pi by 2 minus theta. I think you know this very well. It is in first quadrant, and in
10,
first quadrant
10.
all the ratios are positive. So 10.
Tan theta. Yes, sir.
Yes. So we'll go through few examples. So examples are very simple. Let me change the page. So the examples are very simple. We'll go through few examples. Run. Expand following functions. Expand following functions. Right. 1. Sine inverse. So done. Let
Sir, we
y
have to put x equal to tan theta.
very good. Y equal to sine inverse of 2x divided by 1 plus x square. Done. Let or substitute x equal to tan theta. So what is the theta? Tan inverse x. So it is sine inverse 2 tan theta divided by 1 plus tan square theta. So sine inverse of 2, what is 2 tan theta divided by 1 plus tan square theta? Sine 2 theta.
Yes, sin 2 theta.
Yes, sir. Yes, sir.
So 2 theta. That is 2 tan inverse x.
Yes, sir.
And we know what is tan inverse x is. Standard expansion of tan inverse x is known to us. Use that. X second.
Sir, there should be no 2, no.
Why? No any problem, no?
Sir, 2 tan theta upon 1 plus tan square theta is sin 2 theta.
Ha, correct.
So why
Ah,
next step 2 sin 2 theta?
2
No,
sin
no.
2 theta is not
Yes, sir.
there. Sin 2 theta is there.
Sir, 2 sin 2 theta you wrote. So we
No,
should
no,
not
this
have.
2 you are saying, na? This 2 you are saying, na?
Yes,
Yes.
sir.
Ah, it is not there.
नाही रे साइन साइन कट झाल्यावर तो थिटा राहिला
Oh.
And see, if 2 is here or any number is here, na?
Yes, sir. Yes, sir.
We cannot cancel sin theta, na?
yes sir
Right. Okay, next. Okay, simple example. Let us expand. Cos inverse of 4x cube minus 3x.
Y equal to cos theta.
Yes.
sir.
So cos inverse of and we know the standard expansion. Write the standard expansion pi by 2 minus x plus 1 upon 2 cube by 3 plus 1 upon 2, 3 by 4, x raised to 5 by 5. This is the answer. Next. Page number 14. Let's expand.
So can you please show a previous slide on it?
Now it is not possible.
Okay.
Once I change the page, here one drawback is there. I cannot go to the previous page. Then I have to close it. Then everything will be saved, and then I can go to the previous page. So let expand. If anything is remaining, I am posting it on the Google Classroom. You can take it from there. Yes, Radha. Y equal to cos inverse of x raised to minus 1 means 1 upon x.
1 upon x.
Absolutely. Simplify this. X square minus 1 by x. X square plus 1 by x. We can cancel this x. So substitute x equal to tan theta. Tan inverse x, and therefore we have so you might have understood it is required to take minus 1 common.
Yes, sir.
Yes. And then we have written the formula how we can cancel this minus sign.
Cos pi by 2 minus pi plus minus 2
Pi
theta.
plus minus 2 theta. Theta is
2 tan inverse x.
yes, and then final answer. And I think we should stop here. X plus x cube by 3 minus na?
Yes, sir. Plus x.
This is the answer. Yes. Few examples for homework up to this type. It will be given to you today. Okay, thank you. How much is the attendance? Let me check the attendance. 53 only or 63. Okay.